This is a video from section 12.4 and it's based off the lecture notes. Recall that I is the vector 1, 0, 0. J is the vector 0, 1, 0. K is the vector 0, 0, 1. So graphically, to draw the vector I, we're going to start at the origin and we're going to move one unit along the positive x-axis. So that's highlighted in red here. To get J, we're going to start at the origin and we're going to move one unit along the y-axis right here. And to get K, we're going to start at the origin and we're going to move one unit up along the z-axis in the positive direction. So positive direction for the y-axis and positive direction for the z-axis. And that gives you a visual representation of I, J, and K. Now we can show that I cross J produces K. J cross K produces I, and K cross I produces J. Now if I cross J gives me K, J cross I gives me negative K from the properties of vectors. If J cross K gives me I, K cross J gives me negative I. And if K cross I produces J, then I cross K produces negative J. Now, we want to take a look at K cross I minus 2J. So in other words, K cross the quantity I minus 2J. And we want to figure out this vector without using any kind of determinant notation. But from the properties of cross products, keep in mind that I can take K cross I, okay? I can take this quantity and subtract K cross 2J. So I would probably add that line here. And then from here, I get the quantity K cross I minus 2. So notice I'm bringing the 2 out in front and multiplying by the quantity K cross J. But K cross I gives me J. K cross J gives me negative I. So I get J minus 2 times negative I. And so the answer is 2I plus J, or the vector 2, 1, 0. And so notice we didn't set up one single determinant. Now let's take a look at the volume of a parallelepiped determined by vectors A, B, and C. So notice how the base of this parallelepiped is a parallelogram, and the vector starting here and going this way, highlighted in blue, is C, and the vector highlighted in red going over here is B. And if I apply the right-hand rule, if I take B cross C, I get a vector that runs perpendicular to both B and C pointed in the upward direction. And so that's the vector here highlighted in red. Now, if I draw this line here, okay, I get H. So in other words, I get the height of the parallelepiped. And if you notice, if I take H, right, so by the way, theta is the angle between A and B cross C. If I take H and I divide it by the magnitude of A, I get cosine theta. If I multiply both sides by the magnitude of A, I get H equals the magnitude of A cosine theta. So I'm laying the groundwork here to get the volume. Now, the volume is the area of the base times the height. Now, the base of the parallelepiped is a parallelogram determined by vectors B and C. And so the area of the base ends up being the magnitude of B cross C. And we call the height of the parallelepiped H. Now, this is the magnitude of B cross C times the magnitude of A times the absolute value of cosine of theta. Now you might ask, why did I multiply by the absolute value of cosine theta? It is possible that theta can be greater than pi over 2. And if theta is greater than pi over 2, and you don't have absolute value bars around the cosine theta, then you're going to end up with a negative volume, and we don't want that. And so if we put absolute value bars around cosine theta, you're basically ensuring that you're going to get a non-negative result for the volume of that parallelepiped. Now, let's recall something. So if this is A and this is B cross C, okay, suppose, and theta is the angle between A and B cross C, I can replace cosine of theta with the dot product of A with B cross C divided by the magnitude of A times the magnitude of B cross C. And then I'm just going to put absolute value bars around that quantity. Now, if you notice, the magnitude of A is going to cancel. The magnitude of B cross C is going to cancel. And what we have left is the absolute value of A dotted with B cross C. And that's how you get the volume of a parallelepiped. So I started off essentially with the area of the base times the height, and that idea is going to come back again and again and again. Okay. Now, let's take a look at an example. Suppose I said find the volume of a parallelepiped determined by the vectors A, B, and C. So we did all this hard work, okay? Now, A is the vector 1, 1, 0, B is the vector 0, 1, 1, and C is the vector 1, 1, 1. If I take a look at B cross C, I claim you get the vector 0, 1, negative 1. Now, A is the vector 1, 1, 0. So I do all this hard work, right? I get B cross C, I get A. Now I'm going to take the dot product of A with B cross C. And when I take its dot product, I get 1. And so the volume of this parallelepiped will be the absolute value of A dotted with B cross C. And so essentially I'm taking the absolute value of 1, which is 1. Okay, and that's going to do it for this video for section 12.4. And we made a video here based off the lecture notes. Thank you.